Okay, we're ready for video number 2 on linear functions and slope. So we do know how to look at an equation and determine is it linear, and further, if it is linear, we know how to tell is it tilted, horizontal, or vertical. So let's suppose that you have an equation they gave you and they asked you is it tilted, horizontal, or vertical, and you know that it's a tilted line. The question now is there any way to know which way it's tilted? In other words, if it's a tilted line and the equation has both x and y, how can I determine if it is tilted uphill or tilted downhill? Now, the example that I gave you here on the screen is a line that is tilted uphill. So we know we're going uphill. Now, when it's an uphill line, we said that the slope of the line or the tilt of the line is in a positive direction. So the slope is a tool that we're going to use to help us analyze the line, the tilted line, and know which way it's going. And the slope is a number. It's an actual number that quantifies the tilt of the line. All right, so here's some examples. I have 4 lines here on this screen. All 4 lines are going uphill. Some of them are more steep and some of them are less steep, but all of them are uphill. All right, so all of them have a positive slope. So how am I supposed to distinguish one from the other than saying they're uphill? How do I tell the difference between them? The difference is the amount of tilt that they have. So here's how it works. The slope will be a positive number, but the steeper uphill the line is, the larger the positive number representing the slope will be. The flatter or shallower the steepness of the line, then the smaller the positive number. So, for example, if we were going to guesstimate looking at these, let's estimate the slope of what the lines might be. So let's start with this first one here. Let's say it is uphill, so I know the slope will be a positive number. So I'm going to say the slope here, if I just start in the middle somewhere, let's say the slope here is 4, okay? Positive 4. Well, look at the next line. If I try to compare the second line to the first line, is this line steeper? Would it be harder to pedal your bike up the second hill or the first hill? It's steeper, okay? So you can look at it and see it's going more uphill than the first line. That means that the numeric number for the slope will be a higher number. The steeper the line, the higher the number. So on the second line here, I can estimate the slope. Let's say the slope might be 6. More than 4, you could pick 5, whatever, we're just estimating. This one is steeper even than the first 2. So this one, I'm going to say the slope here is 8. Okay. Now, what about the slope on the last line? Is it steeper or less steep than all the other lines? Do you see how this is a very, very tiny uphill? It's like a ramp. It's not even really a hill. It's just straight little, very, very small uphill grade. So here I'll say the slope is positive 1/2. Okay, does that make sense? So the steeper the uphill climb, the higher the numeric value of your slope. The smaller the hill is, or the smaller the incline is, then the smaller the number is for the slope. I hope that makes sense. All right, so here's another example. And this is the actual slopes here. The first line has a positive slope. This is a slope. Oh yeah, and for whatever reason, in mathematics, when they use the word slope, they're never going to write the whole word slope because we're so lazy in math. We have symbols for everything. So instead of writing slope, the variable of choice to mean the word slope is the variable m. So when you see m, I want your brain to think slope. So m, the slope of the first line here is positive 1. That goes right through the middle of quadrant 1 and 3. All right. The second line is not as steep, and so the slope is a smaller number, 1/2, still positive. The third line is even less steep, and the slope of this third line is 1/10. And then finally, I have a horizontal flat line going across there. So I want you to imagine the line just starts to decline. It gets lower and lower and lower until it's flat. This this horizontal line and every other horizontal line has a slope of 0. Okay. All right. So as the as the lines get more and more flattened out, as we go from a steep line to a flat horizontal line, the numeric value of the slope gets smaller and smaller and goes towards 0. Okay, we can also do this with negative slopes. Remember, if you're going downhill, the slopes are negative numbers. And so we're going to start here at the 0. So the first line here is a 0 slope line. It is horizontal. And if my line were to begin to tilt downhill, then I would have a negative number for the slope. The more negative it gets, the larger the negative number. Now we need to talk about that too. When you have a large negative number, so when people, this can be a little confusing. When you're comparing, say, -10 to -1, people can think about this number -10 as being a larger negative number because they think about 10 being larger than 1. They're both negative. So sometimes we refer to it as a larger looking negative number. Okay. In fact, it's not a larger number though, because on the number line, -1 is over here close to 0 and -10 is down here. -10 is actually smaller in quantity than -1 because it's further to the left on the number line. So the wording here can be a little bit confusing. So I just refer to this as a larger negative number, meaning farther to the left on the number line, even though the quantity is smaller anyway. I hope I'm not confusing you too much. Just think about it this way. The steeper the downhill decline in your line, if it is steeper in the downhill direction, then it has a larger negative number for the slope. Okay. All right. So let's see if we can quantify this. So here, the first one is horizontal. It has a 0 slope. The second line is just barely downhill. It's almost horizontal, just barely tilted downhill. It has a very tiny negative number, 1/10. Okay, -1/10. The third line is more downhill, so it has a larger negative number. This is negative 1/2. So think about it in decimal form. This would be -0.1. This would be -0.5. This is more negative. It has a larger negative number. Okay. And then the last one is even more steep in the negative direction, more steep downhill, has a larger negative number still. Okay. So the steeper you go downhill, the larger the negative number is. All right. So let's see. So let's just practice a couple of ideas here. I just want you to be able to look at a line and determine, is it tilted horizontal or vertical? What kind of slope does it have? So we'll just kind of play here with this. All right. So let's say I draw a line and the line looks like this. Okay. So we would look at this and we would say it is tilted and it is a positive slope. Okay, going uphill, positive slope. All right, example number 2. We would say, let's say we do something like this. This is fairly steep in a downhill direction. Pretend it looks straight, use your imagination. So again, this is tilted and it is a negative slope. The slope would be a negative number because we're going downhill. Okay, third, what if you have something like this one? All right, so again, this would be tilted and a negative slope. Okay. right. What kind of line is this and what kind of slope is it? So it'd be vertical line. Do you remember the equation for a vertical line? Vertical lines only have x. This would be x equals a number. Okay, I don't know exactly what number, but x equals a number is your vertical line. What kind of slope does this have? Can you ride your bike up a wall? No, this is undefined. The slope is undefined. Okay, all right, so just a little, hopefully getting you thinking about how to analyze things just by looking. All right, so again, tilted lines, horizontal lines, vertical lines. Okay, so let's think about let's see. I'm gonna find a nice graphical example for us to do here. Okay, here we go. Here's the example I want to do. This is completely visual from the graphs. Now, I know you look at this and your eyes may go crazy. Look at the image carefully. There's an XY axis. We're in the XY plane, and there are 4 different lines. There's a black line, which we're calling line number C. There's a blue line, line number B. There's a red line, line A, and there's a gold line, line D. So we have A, B, C, D. Okay, 4 different lines here. Now, they ask us to list the lines by slope in ascending order. Now, ascending means from the smallest numeric slope to the largest numeric slope. All right, so I want you to just think about what we're talking about, whether it's uphill, downhill, how steep is it, etc. So the easiest way to do this and to answer this question is to think about starting with a number line. So I put a number line on here. Okay, so it's just a generic number line as a tool to help us here. So we're going to think about estimating. I can't tell you exactly what the numbers are for the slopes here, but we can estimate them. And so when I start this, I'm going to start with the black line, line number C. And we're going to look at this line. Okay, I hope you guys can see my cursor. I'm not sure if it'll show up in the video or not. But if you look at the black line, line number C, maybe I'll just put some highlights on it to make sure we're all looking at the same thing. All right, so I'm going to put some arrows on the end of the line, and I'm going to kind of scribble over the line. All right, so we're looking at line number C here. I want to know, I want to forget about everything else on the page except for line number C. Is this tilted horizontal or vertical? It is a tilted line, we know that. Is this uphill tilted or downhill tilted? So it's uphill. What does that mean about the slope? If it's uphill, then that means that my slope is a positive number. So the slope for line C will be a positive number. Now, I don't know exactly what number it is. I just know it's positive. So on my number line, if I were to put the slope for line C on the number line, I'm going to put it up here somewhere on the right side of 0 on the number line because it's a positive number. Does that make sense? Okay, so all we're doing is the black line, C. So I'm going to label my number line with a C to represent the slope of line C. And notice how we put that over on the right side of 0 on my number line. So I know I have a positive slope over here. Okay, so now I'm going to cross out, I put a little red X over the C. I'm done with the black line. I don't have to look at that anymore or think about that anymore. Let's go over to line number B, or line labeled B. Now this line B is the one in blue. All right, so this line, if we focus on this line this time, so again, I'm just going to kind of scribble on it to draw your eye to it. All right, so this line is a tilted line. And if we read the line from left to right, it is an uphill line again. The question I have, well, okay, so if it's uphill, the slope will be a positive number. Now, here's the question. Is the tilt of line B bigger or smaller than the tilt of line C? Line C was a positive slope. Line B is a positive slope. The steeper the line, the larger the number of the slope. So do you see that B is tilted more in the positive direction than C was? All right, so what does that mean? When I go over to my number line and I put my numeric value for the slope of line B, I'm going to have to put B up here farther to the right on the number line beyond C because it's a bigger positive number. It's a steeper positive line. It has a bigger positive slope. All right, so here's what it looks like. So we are done with line C. We are done with line B. Let's keep going around. Let's look at line A. Line A is the line in red. All right, so we're focusing on the red line. As I read this line from left to right on the page, it is going downhill. So because it is a downhill line, that means that the numeric value of my slope will be a negative number. So I can put it anywhere to the left of 0 on my number line because it's negative. So I know it's not on the right side of the number line, it's on the left side of the number line. So we're going to label our number line and put A down on the negative side of the number line. The last line to consider is line D. Line D is our gold line. All right, so when we're looking at this gold line, as we look at it from left to right, is this line going uphill or downhill? Okay, it's going downhill. So downhill means what kind of slope? Slope will be a negative number. All right, so we already have a negative number slope with line A. We have to compare the negative line A with the negative line D. Which of the lines, A or D, is more steep in the negative direction? Okay, A is more steep than D. So A has a larger negative number than D. So I'm going to have to put D up here on the negative side of the number line, but it has to be closer into 0 than the number A because D is not as steep as line A. So I hope this makes sense. So here's our order. And again, I just drew my number line here as a tool to help me. And what that does is it shows me how to list my answer. The answer to this question is A, D, C, B. And if I had to answer this question in my math lab, I would literally type in A, D, C, B. That's what they want. All right, so I hope that helps. So you can visually analyze your slope of your line and you know uphill, and the more uphill you are, the higher the positive number, the more downhill you are, the larger the negative number. And so you can quantify slope with an actual numeric value. Okay, so back to this idea of slope. That's great. If you have the pictures in front of you and you have the graphs in front of you, you can compare one line slope to another by looking at how tilted they are. But let's say you don't have that. What if you have other information? Or what if you want to be more precise and you want to know the actual number that represents the slope of a line instead of just estimating it? You want to actually quantify it with a number. Well, there is a way to do that. We can calculate the numeric value of the slope using what we call the slope formula. I'm sure you've seen this before, probably in high school. So we're going to start here. Suppose that you have two different lines. How many two different points. How many points do you need to draw a line? 2 points. So if you have any 2 points that you would connect with a line, then you can calculate the slope of that line using the actual coordinates of those 2 points. So we have 2 different points here. We'll call the first point number 1, x1, y1. And the second we'll call point number 2. Okay, and it's x2, y2. So they both have an xy coordinate to them. To calculate the slope, we use the slope formula. All right, so you need to memorize this if you don't have it memorized already. The slope is equal to y2 minus y1 over x2 minus x1. The number one mistake that I see students make is they invert the fraction and they put the x stuff on the top and the y stuff on the bottom. So I have a really stupid way of helping you remember that. If I have a fraction bar, think about the x's being on the bottom. The x's are like support for a table, like a picnic table. They look like the legs of a picnic table. On the other hand, the Y, so you know the X's have to go on the bottom to support the table. The Y has to go on the top because it has a tail, and the tail needs somewhere to hang down. So the Y tail has to hang off the table. All right, I know it's dorky, but hopefully it'll help you to remember to put the Y stuff on the top and the X stuff on the bottom. Okay. Now, one other thing. I know you probably have seen this formula. I know you probably have used this formula before. The one thing that will save you points every time is to use parentheses. If you will put parentheses around the two Y values and parentheses around the two X values, you'll never get it wrong. The problem is when you don't use parentheses around those and you have negative numbers for some of these quantities, you do it too fast in your head. It's not just you, it's everybody when they do this, when you're learning math. You do the arithmetic too quickly in your head and you goober it up. If you do the parentheses, you are much less likely to make any mistakes. So I will be using the parentheses and I'll show you what I'm talking about when we do some examples here. All right, so let's start with, oh yeah, there's one other thing before we get to the examples. Slope is also considered the change in Y because the Y stuff is on the top. You know, Y2 minus Y1, X2 minus X1. The change in Y is the difference in the Y coordinates. The change in X is the difference in the X coordinates. Well, graphically, if you're looking at the difference between the two Y values, we're talking about the distance that you're going up and down. We call that the rise. And then the difference in the X coordinates of the 2 points is going horizontally across, and we refer to that as the run. And so because the change in Y is in the numerator and the change in X is in the denominator, our fraction is often called rise over run. Slope is often referred to as the rise in the line over the run in the line. Okay, so let's continue on. Here's some examples. Here's the first example. I pulled this out of a book. It says find the slope of the line passing through the 2 points. So again, we have point number 1 and we have point number 2. Okay, so we're going to do y2 minus y1 over x2 minus x1. So y2, the second y coordinate is 5, so you literally plug that in for y2. The first y coordinate, y for point number 1 is -2, so you plug that in as y1. Okay, x2 is -1, so we're going to plug this in. Let me change color, maybe that'll help. Okay, so x2 is -1, and that goes right down here in the first place in the denominator, and x1 is 4, and we're going to plug that in over here for x1. All right, so they literally are just popping these numbers into place. Here's where you have to be careful in your head. We have 5 minus a negative number. Well, 5 minus a negative, we're not going to write 5 minus a -2. We never write two negative signs like that in a row. When you have minus a negative, well, there's two negatives together, we make that a plus sign. Minus a negative is plus. On the bottom, -1 minus 4, we don't have a double negative there. We don't have two negatives side by side. So you have two negative numbers here. So this ends up being +7 on the top and -5 on the bottom. Okay. So you end up having -7/5 for your slope. Now, keep in mind, the slope is negative. That means it'll be a downhill line if we were to draw it. Negative numbers can be written in different ways. All right, so I could put the negative sign right in line with the fraction bar. That is what they did right here. -7/5, that's how we would read that number. I could put the negative sign up on top with the 7, and I would read this number as -7/5. Or I could put the negative sign down where the 5 is and make it -5. And I would read this -7/5. It doesn't matter if you put the negative sign with the fraction bar in the numerator or in the denominator, but you got to put it somewhere. You don't want to put it in both the numerator and denominator because then the negatives would cancel out and you would have positive 7/5. So just be careful in how you're writing stuff down. Okay. All right. Now, second thing about this example, they listed the 2 points in this particular problem in a particular order. And so in the problem as it was written for us, we called point number 1 the first ordered pair 4, -2, and we called point number 2 the second ordered pair -1, 5. Well, what would happen if they had them in the reverse order? What if they had not literally in the reverse order? Let me try that again. What if they had written the -1, 5 point first and the 4, -2 point second? Then this would be point 1 and this would be point 2. The question is, does that matter? Does the order of the 2 points matter? Will it change our answer? Well, let's try it. So the slope here will be y2 minus y1 over x2 minus x1. Okay, so we're just going to put our 4 parentheses. This is how you save points. I know it's a pain. I don't care. It'll save you points. The whole point, no pun intended, is for you to keep all of your points and get through this class and move on with your life. So do these tips and it'll help you save your points on your test. All right, so what is y2 in our problem? y2 is the y coordinate for the second point. That would be -2. y2 minus y1. y1 is 5. Over x2, which is 4, minus x1 is -1. So this is going to give me -2 minus 5 on the top. And on the bottom, I'm going to have 4 minus a negative number. I have 2 negatives in a row here. That's going to be 4 plus 1. So I end up having -7 over +5. And this fraction is read as what? -7/5. It's the same answer that we got over here. It doesn't matter which point you're calling point 1 and which point you're calling point 2. The only thing you have to be careful of is if I subtract the y's going this way, I have to subtract the x's going the same way. Okay, so be careful about that. Okay, let's move on. All right, some other examples. You don't always have pretty integer numbers. Sometimes you have fractions. So I didn't want to not do an example for you with that. So here's an example. They want us to find the slope of the line between the given points. Let's say that point number 1 is 1/2 -1, and point number 2 is 3/4 3. Okay, do not let the fractions bother you. We're going to do the same thing we did with the other example. We're going to have y2 minus y1 over x2 minus x1. y2 is 3 minus y1 is -1. x2 is 3/4 minus x1 is 1/2. So I end up having 3 minus a -1 would be 3 plus 1. 3/4 minus 1/2. All right, let's help ourselves here. In order to add or subtract fractions, we need a common denominator. So I need to multiply this second fraction by 2/2. That will force this denominator to be a 4, which is what the other denominator is. So I will have minus 2/4. Okay. All right. So now that will give me 3 plus 1 on the top is 4. 3/4 minus 2/4 would be 1/4. All right, so now you got to go back and remember your algebra. You had algebra before you came to me, so you should know this. So we're going to leave the top fraction written just as it is, 4. Now 4 is really the same as 4/1. Let's write it like this. 4/1, that's what we have in the numerator, 4 or 4/1. And in the denominator, I have 1/4. So you leave the top fraction alone, 4/1, and you multiply by the bottom fraction inverted. So I end up getting 16/1, or 16. Our slope between for this line between these 2 points is positive 16. So will this line be going uphill or downhill? Uphill. Okay, so we have an uphill slope. All right, so that's one example. All right, here's a second example. Find the slope of the line between the 2 points. And let's suppose this time we have the ordered pair -1, 3 and 5, 3. Okay, so slope will be y minus y over x minus x. y2 is 3, y1 is 3, x2 is 5, x1 is -1. So I end up having 3 minus 3 over 5 plus 1. So I get 0 over 6. 0 divided by anything is 0. So my slope for this line is 0. So what does it mean about this line? What do you know about this line? What kind of line has a 0 slope? This is going to be a horizontal line. It doesn't go uphill. It doesn't go downhill. It is a flat street. Okay. All right. Example number 3. Suppose you have 9, -1, and 9, 3. The slope here will be y minus y over x minus x. y2 is 3, y1 is -1, x2 is 9, x1 is 9. So I end up having 3 plus 1 over 9 minus 9. So I have 4 divided by 0. What do you get when you divide any number by 0? If you plug this into your calculator, it is an undefined quantity. It's undefined. What kind of line has a slope that is undefined? This would be a vertical line. You can't ride your bike up a wall, has an undefined slope. Okay. All right. So that's a little bit of practice with our slope formula. So I hope you remember that from high school or from a previous course. Okay, here's the last example for this video. All right, here they want us to find the slope. Instead of giving us the 2 points, they give us a picture. Now, in order to do this effectively, you're going to have to find a couple of points on this line where you can clearly see coordinates. Okay, now there's a bunch of points where it doesn't cross the graph paper grid at a crossing. So for example, if I were trying to do this, I will not choose this point right here on the line because I don't know the exact coordinates for it. You need to pick a point on the line. Let's choose this point on the line. Do you see how this one we can easily see the coordinates for because it crosses on a grid line, crosses at one of those cross marks. So you want to choose points that are crossing like that where you can easily see the coordinates. So if I look at this particular point, go up to the x-axis here, that would be at -5. And on the y-axis down here, it would be at -6. So this first point, we'll just call this point point A. Now I'm going to show you how to do this particular problem 2 different ways. You can do it calculating, and you can do it from the graph by counting. So we're going to do the calculating first. So point A has coordinates -5, -6. So I pulled that from the graph. I just looked for a point that I could easily see the coordinates for. Okay, and I noticed that right here is another point that's really easy to see the coordinates for. The x coordinate is 0 and the y coordinate is -3. So I'm going to call that point B. X is 0, y is -3. So I can find 2 ordered pairs and we can go back and do exactly what we were just doing. Y minus y over x minus x. y2 is -3, y1 is -6, x2 is 0, x1 is -5. So this would give me -3 plus 6. Again, we've got this double negative thing going on in the numerator, so it's a +6. And I have 0 minus a -5, again, a double negative there, so we write +5. So -3 plus 6 is positive 3, and 0 plus 5 is 5. So my slope is 3/5. So that's one way to calculate the slope, is by literally finding the coordinates and just using your slope formula. Now, I can also do this by literally just counting. Remember that slope is rise over run. Okay, that looks like rum. It's not over rum, it's over run. Okay. All right, so let's say that I start at A and I proceed to B. If I start at A and I go to B, and I am only allowed to travel in my little vehicle going from A to B, I can only travel on the grid lines of my graph paper, then I have to be able to count. So the run is how far across we go horizontally. Now, if I am going in the positive x-axis direction, we call the run a positive number. If we are going up in the y direction, we call the run a positive number. If we are going down for the run, we would use a negative number to reflect the run. And if we're going to the left on the x direction, we have a negative number for the run. Okay, so rise and run are going to be positive or negative depending on which way you're going. So if we're going to do this, let me write it this way. Rise over run. Let's start with the number for the run. I'm literally just going to count it out. Get a different color here so you can see what I'm doing. Okay, so I'm counting from A. I'm going to go 1, 2, 3, 4, 5 units over until I'm underneath the point B. So my run is going to be positive 5 because we're going to the right, like the positive direction on the x-axis. The run, if I start here underneath B, I'm going to go up 1, 2, 3. So I rise positive 3. So I've literally just counted and I got exactly the same slope that I did when I calculated it from the ordered pairs. It is your choice. Okay, it's your choice how you want to calculate. So you can count, rise, and run, or you can find two ordered pairs and do it. One last thing. What if I start at point B and I go to point A? All right. So we'll have, again, rise over run, but this time my starting point is point B and my ending point is point A, right? So let me just get rid of all this stuff. Okay, so again, let's just sort of count this out. If I'm starting at point B, I need to travel on the grid lines only. All right, so I'm going straight down here. Oops, I went a little too far, and then straight across. Okay, so I've got to figure out how far down, up or down do I need to go, and how far left or right do I need to go when I start at B and I want to end at A. So if we start with the rise, I'm going 1, 2, 3 units, but we're going down to get to point A. So my rise will be a negative 3, and my run will be 1, 2, 3, 4, 5, and we're going to the left. So it will be a negative 5 and negative 3 over negative 5. Those two negative signs are going to cancel out, and I'm going to end up with 3/5 again. Okay, so just be careful when you're counting it out. Make sure you're thinking about the direction that you're going. All right, that's it for this video. I'll see you guys in the next one.